Assalamualaikum dan salam sejahtera. Okay, today we are going to continue our lesson in chapter 3, Redox, part 3. Okay, so in the previous lesson we have learned the two reactions. They are the displacement of metal from its salt and displacement of halogen from its halide solution. So today we are going to learn the third and the fourth reaction, which is the change of ion to ions to ion 3 ions and vice versa. Okay, so this is the ion 2 and ion 3 ions, the color of the ion. Okay, so the first one, ion to ion, is green in color when in solid and aqueous solution. For example, ion to chloride. Okay, so here we know that the ion used is ion to ion. Since we can refer to the formula of the compound FeCl2, we cross Fe2 plus with Cl minus, so we get FeCl2, meaning the ion used is ion to ion. Okay, whereas for the second diagram, the brown color is for the ion 3 ion. Okay, so from the name we can differentiate it is ion 3 ion, and then we crossed Fe3 plus with Cl minus, then we get FeCl3, meaning the ion used is ion 3 ion, so the color is brown. So this is how you differentiate between two type of ions. Okay, ion to ion is green and ion 3 ion is brown in color. Very important for you to know and memorize the color of the ions. Okay, look at the first reaction, which is the change of ion to ion 3 ion in your module page 112 and 113. Okay, this is the reaction. Okay, so the first reactant is ion 2 sulfate solution, and the second reactant is the bromine liquid. Okay, so when bromine liquid is added or reacts with ion 2 sulfate, so this is the step you must remember. You must know how to describe the reaction. Okay, the first step is to identify the reactant used, whether it is ion 2 or ion 3. So in order to know the reaction ni adalah conversion of ion 2 to ion 3 ataupun ion 3 to ion 2, kita kena tengok dahulu reactant dia guna ion 2 ke ion 3. Okay, so for this case dia guna ion 2 sulfate, bermakna dia guna ion 2. So automatically this reaction akan jadi ion to ion nak convert kepada ion 3 ion. Okay, so kita dah tahu reactant mana, reaction mana, jadi baru kita boleh buat half equation. Okay, so for this case, from Fe2 plus to Fe3 plus. So very clear, it is oxidation because from 2 plus changes to 3 plus. Okay, the oxidation number is increase, jadi dia adalah oxidation. Okay, and then baru kita akan explain the reaction in terms of redox reaction, macam biasalah. Kita tengok explanation. Okay, so the first one is kita write the half equation for the oxidation. Since kita dah tahu dah dia nak convert ion 2 jadi ion 3. Okay, so just terus tulis saja Fe2 produce Fe3 plus. So it is oxidation, so the electron is donated. Okay, ataupun losses of electron. Jadi electron duduk sebelah sini sebanyak 1 electron. Kenapa 1? Because dia berubah from 2 plus kepada 3 plus. Jadi cuma 1 sahaja electron yang di derma. Okay, let's say kalau daripada contoh from 2 plus to 4 plus, jadi bermakna 2 electron. For this case dia 1 saja. Kenapa duduk belah sini? Because dia oxidation, dia lose electron. Okay, so explanation, Macam biasa juga, Fe2 plus ion loses 1 electron, correction 1 electron to form Fe3 plus ion. So di sini bromine liquid, which is another reactant, will act as oxidizing agent. Okay, so observation kita tengok. From Fe2, which is green in color, changes into, after the reaction, Fe3, which is brown in color. So we can say ion 2 sulfate solution ni asal ni changes from green to pale brown. Okay, so next dia ada additional item untuk for this reaction, which is confirmatory test, ujian pengesahan ion apa yang present dalam reaction ni after the reaction. Okay, so tadi kita dah tahu dah dia akan produce Fe3 plus. Jadi so Fe3 plus ni confirmatory test you have learned during chapter 8 salt. Okay, what is the reagent used to identify the Fe3 plus? So the brown precipitate is formed when it is tested with excess NaO. Biasa kita guna NaO kan untuk identify cation. So dia akan produce brown precipitate bila kita tambah NaO dalam ni nanti. So itu mengesahkan kehadiran Fe3 plus. So the inference is Fe3 plus ion is present. So membuktikan ini adalah proses oxidation, iaitu Fe2 dah berubah jadi Fe3. Okay. So next kita tengok the second process, which is reduction occurs to bromine liquid. Okay, so here bromine liquid Br2 change into, converted into bromide ion. Okay, so this is the reduction process. Dia automatically dia satu tadi oxidation, this one must be reduction. So you pun balance lah equation. So sini Br2, sini tadi Br minus, jadi jadikan dia 2, jadi 2 negatif. So elektron pun sebelah sini dia mesti gain elektron sebanyak 2 because dia reduction. Okay, so you can explain bromine molecule ataupun bromine gains 2 electron to form bromide ion. Okay, so here ion 2 sulfate, another reactant, will act as a reducing agent. Okay, then observation. Okay, tengok. Okay, this one is halogen. After the reaction, it becomes halide. So ingat, halogen ada color, halide tak ada color. Okay, so from brown color, bromine is brown. Okay, remember bromine color is brown, turns into colorless because it is halide. Dalam bentuk ion ni dia halide. Okay, kalau chlorine, chlorine warna yellow. Kalau dia jadi halide, chloride warna colorless. Sama macam sebelum ni juga. Okay, for this case kita tak ada confirmatory test. Okay, actually ada untuk bromine, you dah belajar, cuma cikgu tak concern sangat for this case. So, biasa kita concern untuk cation sahaja, confirmatory test. Okay, so the ionic equation. Okay, cikgu akan terangkan in the next slide. Okay, so in another way, you can write the equation ataupun you can describe the reaction by using this table. Okay, cikgu prefer this one for task. After this, you must use this table. Okay, so how to get the ionic equation? Jadi, we have to combine both half equation. So, tengok kat sini, elektron dia tak sama kan. Sebelah oxidation ada 1, sebelah reduction ada 2. Jadi in order to cancel off the electron, we must equalize, samakan dia punya bilangan elektron. Jadi sebelah sini kita kena darab dengan 2. Jadi sini akan darab 2 Fe. That's why sini dapat 2 Fe. Okay, belah reaktan belah sini bromine 1 saja, tak payah darab. Bromine 1 settle belah reaktan, produce belah produk pula Fe2 3+. Okay, ini pun tadi kita darab dengan 2 kan. Okay, darab 2 dapat 2 Fe plus tambah 2 Br minus yang ini. Okay, elektron dah tak ada sebab sini dah ada 2 tadi, cancel dengan sebelah sini 2. That's why kena samakan dia punya elektron supaya kita boleh cancel off. That's why kita dapat ionic equation macam ni. Ni cikgu dah ajar dah masa form 4 dulu, recall balik. Okay, Next is the common oxidizing use. Okay, for this reaction, since it is oxidation, jadi ada a few oxidizing agent yang you kena remember. Okay, kebiasaannya adalah halogen. Macam tadi kita guna chlorine kan, jadi boleh guna bromine kadang-kadang, bromine water and chlorine water. Okay, then okay, dua beradik ni acidified. The first one acidified potassium manganate 7 solution and acidified potassium dichromate 5 solution. Okay, jadi apa yang bezanya nanti sini je kita tukar. Kita tak nak guna bromine, kita boleh guna KMNO4. Tak nak guna yang tu, boleh guna lagi satu potassium dichromate. Okay, apa bezanya nanti dia punya observation. Kalau guna yang ni potassium manganate, dia akan berubah from purple to colorless. Kalau guna acidified potassium dichromate, dia akan jadi orange to green solution. Okay, itu sahaja. Okay, your task 3 in page 113, complete example 1 and 2 by using this table. Okay, alright. Now we move to the second reaction, which is the change of ion 3 ion to ion 2 ion in your book, page 114, 115. Okay, sekarang kita balik. Tadi dari air 2 nak pergi 3, sekarang dari 3 nak pergi 2. Okay. So, macam tadi juga, kita kena tahu the step how to solve the problem. So, the first step is identify the reactant used in the reaction, whether it is ion 2 or ion 3. So for example, for this case, dia cakap zinc powder. Okay, ni zinc powder, zinc metal is reacts with ion 3 sulfate solution. Okay, di sini dah jelas. Kita tahu dia punya reactant ion 3, bermakna automatically kita nak convert dia jadi ion 2. Okay, so sini dah clear dah, from 3 plus convert jadi 2 plus, bermakna dia dah reduce dia punya oxidation number, bermakna dia adalah reduction process. Okay, so write the half equation for the change of ion 3 to ion 2 and then explain macam biasa. Okay, so since this reaction kita dah jelas dah, ion 3 pergi ion 2 is a reduction, jadi terus kita buat bahagian reduction dulu. Okay, so Fe3 plus convert into Fe2 plus, so it is a reduction process, so it must gain an electron. So that's why electron duduk belah sini, because reduction is a process where it gain the electron. So gain sebanyak 1 electron, sama macam tadi juga, because dia berubah daripada 3 kepada 2, jadi pengurangan 1 sahaja kan, jadi 1 electron sahaja. Or in other words, Fe3 ions gain electron or been reduced to form Fe2 ions. Okay, zinc will act as a reducing agent. Okay, so for observation, tengok. So from before reaction is Fe3 plus, which is brown in color. After the reaction, it becomes Fe2 plus, green in color. So the brown color of ion 3 sulfate, warna brown, will turns into green, which is Fe2 plus. So confirmatory test to test Fe2 plus, okay, kena guna NaO juga. So dia akan produce dirty green precipitate. Samalah sebab tadi warna hijau kan, akan jadi warna green lah. Sebab dia jadi Fe2 plus is formed when tested with excess NaO and insoluble in excess NaO. So inference, it will confirm Fe2 plus ion is present. Okay, very simple. So next kita tengok pada oxidation process. So another reactant is zinc powder automatically. So kat sini zinc powder. Okay, it's a zinc metal. After the reaction we come zinc chloride. Tak ada benda lain lah daripada atom, dia akan jadi ion because of oxidation. So from 0 to 2 plus. So oxidation nama dia dah increase from kosong jadi 2 plus. So di sini bermakna dia proses oxidation. So it lose 2 electron. Kenapa 2 electron? Because 2 plus. Okay. So kita, in other words, we can say zinc atom loses 2 electron to form zinc ions. Ataupun in other word, we can say oxidized. Okay. So di sini ion 3 sulfate automatically will act as a oxidizing agent. Okay, so observation, So from zinc metal dissolve to become zinc ion. So from metal ni after reaction metal ni tak ada dah. Ketinggal sikit. Okay, dia akan jadi ion. Zinc metal will dissolve. Okay, kalau you guna kepingan, you cakap zinc metal becomes thinner. Sekarang dia guna powder. Jadi kita guna perkataan dissolve. Okay, so for confirmatory test also you have learned in chapter 7 for zinc ions. Okay, what precipitate is formed and dissolved in excess NaO. Also kita test menggunakan NaO solution. So apa berlaku akan dia akan produce what precipitate. Itu mengesahkan zinc 2 ions is present. So last kali dah dapat both half equation, kita kena buat ionic equation ataupun overall equation. Sama macam tadi juga. So sini kena darab dengan 2. Semua darab 2. So barulah boleh cancel off elektron. Jadi tulis balik bahagian reaktan ada 2 Fe setelah didarab dengan 2. Belah sini ada 1 zinc to produce belah produk ada 2 Fe2 plus dan 1 Zn2 plus. Okay, very easy. So macam tadi juga, this process kita kena ingat some common reducing agent. Kalau tadi oxidizing agent, sekarang reducing agent. So for example, biasanya kita akan guna metal yang reaktif, such as zinc powder dengan magnesium powder. Okey, kalau metal lain boleh tak? Contohnya group 1 kan, sodium, sodium, potassium. Okey, pun boleh tetapi tidak practical because metal group 1 is very reactive. Okey, dia meletup-letup. Okey, jadi tak praktikal nak guna. That's why kita guna yang less reaktif sikit seperti magnesium dan zinc. Dia reaktif tapi tidaklah sereaktif group 1 metal. Okay, another reducing agent can be used is halide solution. Okay, ingat halide. So bila halide dia dalam bentuk garam ataupun compound. So contohnya potassium chloride. So dalam ni ada halogen, itu chloride. Okay, sodium chloride pun ada chlorine, ada chloride. Potassium bromide, ada bromine. Okay, this one you have to memorize lah. Okay. So the next task is task 4 in your module page 115, example 1 and 2. So by using this table, solve the problem given. Okay, so we have done 4 reaction in redox reaction. So the rest, tinggal number 5, transfer of electron at a distance, will be discussed in the next class. Okay, thank you very much.